All right.
Why is that so bright?
What chapter is it?
This is going to be 11.3.
Okay. Exactly. I can't use that. I usually use that.
Do you promise me that? No PowerPoint today? I'm a little out of it.
Nope. All right, the dot product. Okay. The dot product is a way for us to multiply vectors and obtain a scalar. Once we get into 3 dimensions, I will teach you how to multiply 2 vectors to get a vector, but that won't be until the spring. Okay. So if we have vector u and vector v, then our dot product, u dot v,
I feel like
No.
It's like the outsides, and like you multiply the outsides and you multiply the insides, and then you add them together.
I don't know what you're referring to as outside and
V1
inside.
times V2.
Uh,
I used to keep the same one.
yes, you multiply the same components together.
Is it called?
So there's 2 ways to multiply vectors, and so we have 2 notations. This is the dot product. When we get into 3 dimensions, we'll talk about the cross product. Both mean multiplication. Are you not okay with that?
Well, I just feel like if it's multiplication, then you're still. The fact that you get a different answer from multiplying it and using the same operation. Hurts me. But
Okay.
it is. You're multiplying numbers. One of them you're using a different format. Like, what if you had an asterisk? Then what would you do?
If 1 to the infinity cannot be 1, then I think we can have two different types of multiplication. That's how I feel about it.
Find the dot product. Find the dot product. Gabe, what do you get?
Negative.
Can you explain to me what you did?
Well, so u1 times v1, which was 1 times -2, and I added 1
Definitely heard that as 37. So.
I
I was like, gee, someone didn't close the thing. 37 is a big number, but that's just that is.
So what'd you get?
Sorry, that is a chevron.
It's or something.
We don't want to talk about it.
You said negative 1.
At least you're on the right track.
Okay.
That's only 3rd hour. It's been a long day.
It's only Monday.
That's only Monday. It's been a long week.
The dot product is commutative. Do you believe it?
I believe it.
Wait, what?
And multiplication. So both of which are commutative.
Wait, did you say
Seconds
cross
away from
multiplication?
My use and
It's not.
I have to.
What?
Otherwise, I will go like.
Matrix multiplication is commutative, remember?
Matrix
I don't
is
know.
really complicated now.
My
Like,
knees
I
really
remember
hurt.
matrix multiplication
I
was
don't
like some
know
process of doing all
anything.
this stuff.
I don't know anything.
Like I remember I had to like go down a bunch of diagonal lines to multiply with my hands. It was just
Okay, the dot product is distributive.
sucks? Mr. Becky doesn't have any clinics sometimes.
That's a silly man.
Extras. Well, I like rolled in here and used 5 or 6 consequences.
Okay, C is a constant. What are all the operations happening in this property?
You got a scalar going on after the product.
Okay, and what is the operation attached to the scalar?
Multiplication.
Multiplication. So we are multiplying, right?
Yes.
If I asked you to do 2 times 3 times 5, would you do 2 times 3 and 2 times 5? No. You would like do a multiplication and then take that product with the other one, right?
Yeah.
Same thing. We could take the scalar to u and then dot it with v, or we could take the scalar to v and then dot product with u. But we can't distribute multiplication to multiplication. That doesn't make sense. Okay? I know these are all kind of boring properties, but what happens if I gave you the dot product of a vector and the 0 vector? You would get 0. Okay. That one's not exciting. We're not going to write it down. This one is exciting, though.
I thought that was a good question for a second.
There's a question on the homework last night about if you have certain given vector and it's going in a certain given direction, you can tell the direction was just straight.
Okay. Let's talk through this one. Any thoughts on why this is what it is?
Is it v squared?
What does this mean? Magnitude.
Oh, 'cause- yeah.
So if we took the dot product, we would take v1 times v1, right? And we would take v2 times v2. And
then that's
this is what's underneath the radical. So when we square it, the radical goes away. Not very exciting. Okay, what can we do with the cross product?
Get an A on the quiz.
Wait, you just said we weren't doing cross product, didn't you?
Sorry,
Oh.
what would we do without the dot product?
Get an A on the quiz.
The angle between the vectors. I'm
It's,
guessing it's what you just wrote.
it's positivity. With this dot product, I'm going to get an A on that quiz.
Just dot product every single problem. Yes.
It's a parametric one, and I'm like, we going to do dot product. How does that work?
We can find the angle in between two vectors without having to do any sort of triangle calculation, because this is doing it for you.
Oh.
Okay? The proof of this is actually a law of cosines,
Likes those.
but we're not gonna go through the proof. I'm hoping that maybe you recognize this from pre-calculus. Okay?
I do.
But if you have two vectors, we can figure out the angle between them by taking their dot product divided by the product of their magnitudes, inverse cosine. Yes.
This is just a weird question. Could you actually write the magnitude of u and magnitude of v right next to one another? You just have like 4 lines.
Isn't that what I did? I mean, technically. Would you like me to move them closer?
No, I just know you can like write uv, but I mean, sometimes they have you do stuff in parentheses.
Okay, so what were those two, what were the U and V that I had you, was it
1, 3.
1, 3, or 137?
Sometimes it's just a Monday, and you can't read, and that's just how it is.
Is it a Monday?
It's a,
It officially is a Monday, but it feels like your Thursday, right?
no, it feels like
It
a
feels
Monday.
like Friday
it
plus
feels
one.
It's a month or. Quad thirds.
All right. What did we decide the dot product was? Negative half. Thank you, Amy. If we were to find the magnitude of u, it would give us 1 squared plus 3 squared would be 10, so we have the square root of 10. This magnitude would be
17. Yeah, square root of 17.
okay. So what we can do is we could put this ugly fraction in our calculator and take the inverse cosine of it. Now, please remember order of operations. If we have a product in the denominator, you're going to want to put that product in parentheses so that all of it gets divided and not just the first one. So please practice this with your calculator. Take the inverse cosine of that gross fraction and tell me in degrees what the angle is in between these two.
Is it going to dip it in decrease it?
I don't really care.
But when you do, oh, right.
I love the check. Okay. Your calculator. It's up to your calculator.
Yeah.
If your calculator's in degree mode, it'll give it to you in degree.
What if it's in like temperatures?
It doesn't matter. It's just degrees versus radians.
Wait, would it be like radical 17 over 2?
What are we getting for theta?
94.4 degrees.
Yeah. What?
399. It's the most Monday I've ever had.
Okay, now I have a question. What is the cosine of 90 degrees?
0.
0. Okay. What part of that fraction would need to be 0 for the cosine of theta to equal 0?
Bless you.
Okay, if our numerator is 0, our whole fraction is 0, and we have the cosine of theta equals 0. So what would it mean if our dot product is 0? Okay. If your dot product is 0, then your vectors are, we're going to call them orthogonal.
That's weird.
Okay? We don't call them perpendicular, we call them orthogonal. Okay? In vector world, we need special names. Okay? You know that ortho.
Like orthopedic.
Mm-hmm. Orthodontist.
Teeth.
Okay, you want things to be straight. Or you want your teeth to be making 90-degree angles so that they look nice.
Right there.
Oh my.
Like spirals inwards.
So if I have a question, are these orthogonal? All you would need to do is find the dot product, and if the dot product is 0, your answer would be yes. If the dot product is not 0, your answer would be no. Okay. Did I have one on here?
Is there a special word that they are?
So these two vectors right here, 218 and 3/2, -1/6. If we take their dot product, 2 times 3/2 is 3. plus 18 times negative 1/6 is negative 3. Our vectors are ready for some physics?
No.
You guys act like physics is the worst.
It is the worst. This is the hardest class I've ever taken.
Oh, hard.
Tomorrow.
Hey, I'm here too.
Yeah, and the psych test. And
Those
the
are the
stats
worst, 'cause there's always
scrappy.
just a long CSA.
Oh, what's-
That's garbage.
You know what? Psychology is easy though.
You're so
So I'm not going to write it, but these do need to be non-zero vectors.
Oh, we're stalking.
We're going to talk about the projection of a vector onto another vector.
It's like when you have like a
Stop.
board.
You know what? I didn't.
So this is W, the red vector. The green vector is V. And I want you to imagine that we're going to shine a light down onto V. This is the projection of the projection of V onto W. So the little subscript is W. Okay. V is the regular font. Okay, write it down and then we'll kind of talk it through.
Are we gonna have to have that formula memorized?
Yep. What?
No, not like power tools. Not at all.
Okay, what kind of outcome do you get from a dot product?
A number?
Okay, good. What kind of outcome do you get from a magnitude? Okay, so do you agree that this is all a scalar?
Yes.
So we have a scalar times W,
A vector.
which we would get a vector from. Okay, and it's that guy right there. Now, we can also talk about the decomposition of V.
What would be like a word problem example? Something like that.
Okay, well, could you give me a moment?
Yes.
Thank you. Because we're going to talk about it.
This whole page, I know.
Okay. So I'm going to take this picture. I'm going to copy paste it down. Think that'll work? Look at that. Okay.
It's so fancy.
We also know what this is right here.
Another vector.
And we can find this other vector. How would we be able to find that vector?
find what makes the other one equal 0 and a dot product.
You are right, their dot product should be 0. Okay. What?
I look at my paper.
This vector that I'm drawing in right here, what is it?
Parallel.
Mm-hmm.
Oh, it's like negative information.
Okay. So if I wanted that blue vector, we could take our original v vector and subtract out the projection vector. Oh, dang it. I got too many.
Why would you subtract out the projection?
Well, do you notice how my projection vector is going the opposite direction? So this is how we do vector addition when we put like the initial point of one at the terminal point of the other. Okay? But since it's going this direction, we're actually subtracting it. We're adding
So is
the
that more
opposite.
like a parallelogram than it is a square that looks like?
Well, it is a square because these are going to make a right angle.
Is
With the
is
projection,
V
yeah.
bisecting it?
No.
Then why?
So how are those?
Well, okay, I drew it that V is bisecting it, but it's not
Oh.
always going to.
But like, if it wasn't, you had something like that.
And here would be your projection vector, right? And here would be the opposite vector.
That's right.
And that vector is called that big B composition vector.
How does the book? Basically, we decompose our vector V into the projection and this V2. All right, so let's do some work here. What, Gabe? Did that not get explained
No,
to you?
it's okay. We're good now. I wrote down the equation. It'll probably be the same.
What were you?
Just basic geometry stuff and lacking common sense.
We'll come back to it. Here are our two vectors I want to work with. Where are they? Okay. So if we want the projection of V onto W, we need to take the dot product and divide it by the magnitude squared. So help me out. What do you get for the dot product? 3. We have 2 times 1 plus 1 times 1, which is 3. Okay, and then we're projecting onto W, so we care about W's magnitude. So what is the magnitude of W? So what we have is 3/2 times the vector I plus j. Oh, Lordy me. We always want our projection vector to be parallel to W. That's the whole point of us projecting it onto W. So this will always be a scalar multiple of W. Okay? So just another piece to the formula to let it sink in as to why it's set up the way that it is. Okay? Now, if we want that other vector that's perpendicular to this, right? We are going to take our vector V and subtract our projection vector. Okay, so this component orthogonal to W. What do we get? 1/2 I minus 1/2 J. And see how those would be. A dot product of 0. Okay. So Gabe.
I'm still confident.
What? What did you mumble?
It's still writing.
Oh, okay. Keep writing. We need a code word. While we wait for Gabe.
Waiting for Gabe was the code word.
The code phrase.
Yeah, the code phrase.
Code phrase
That's
is
the
waiting
code
for
word.
Gabe.
Gabe. The code phrase should be what is the code phrase?
Okay.
These-
2 practical examples. Are you ready?
Practical example problems hurt my soul.
A 600-pound boat
That's not a big one.
Yeah.
It's a small one.
sits on a ramp inclined at 30 degrees.
Don't say it, right?
What is the force required
Oh.
Force. At least it's just gonna be magnitude. You don't have to deal with it, right?
to keep the boat from rolling?
I think a picture of this is the screen.
There's your picture, Gabe.
Can we get a sailboat?
You can make it.
Yay!
Am I in it too?
Yeah.
Now we're talking.
Gabe on his little boat.
Okay. This weighs 600 pounds with Gabe in it, we'll see. Okay. The force of gravity is which way?
Down.
Okay. So that vector what? So I'm going to call this our F for force.
600.
Do you agree that this is negative 600 J?
Because it's
I know why it
gravity.
has to be negative.
It's down.
Okay. Now, we're gonna make this vector v. And I'm just gonna call vector v radical 3/2 I plus 1/2 j. Why am I calling it that?
Because you did the substitution and stuff.
And it's a unit vector.
Okay, I'm just making it a unit vector because unit vectors make the world easier. Okay, I could make that vector anything as long as it has a 30-degree angle. Okay, it really doesn't matter right now because it doesn't have a specific value. We're just talking about the ramp. Okay, so the cosine of 30 is radical 3/2. The sine of 30 is 1/2. So now what I want to find is the projection of f onto v. Okay, so how are we going to do that? We're going to take the dot product over, which magnitude do we care about? V squared times v. Okay, well, do you see why I made the vector a unit vector? Okay, our denominator is just going to be 1, right? What's our dot product end up being? Negative 300 times our vector radical 3/2 I plus 1/2 j. Okay, well, if I'm talking about the force to stop this from rolling on the ramp, what do I care about this vector here? What?
It's magnitude. It's magnitude.
We would want the magnitude. So here, our force was 600, has a magnitude of 600, right? Okay. Gabe, are you okay with we need the magnitude? What?
Huh?
We want the magnitude? Okay. So the force to stop it is going to be the magnitude of this.
I meant like f plus the projection of f should equal 0, and then like you stated what I like trying to make them 600.
I see what you're trying to say. Okay. What was the magnitude of this? So a force of 300. You're gonna hate this.
Oh no. Footles. Not the footles.
Wait, force. Force is just pounds. Work is foot pounds. I made you panic for no reason. Now, I am not going to ask you a question like this on tomorrow's quiz. Like, this is pretty in-depth. But I like to connect your physics world with your math world. Okay? But let's do one more example. Are you ready? One more dot product example.
Are you ready?
Apparently I like 30 degrees today. My wagon pulling days are kind of behind me now. Thank you.
You can pull us around in a wagon if you really miss it that much in this moment.
I don't know if I can do that. Man, I used to load up the boys in the wagon and I'd pull that wagon all over the zoo, which is not easy to do in those hills. Zoo.
Yeah.
And my boys are not small.
Big boys.
It's like 30 feet.
Is that 30
Oh.
feet? I was looking at it, I was very confused. I was like, 37?
All right.
I think I picked up on
How do we find work?
Forest and distance.
Okay. So we need the force of the wagon times the distance that it travels. Well, we know that the distance it travels is 30 feet. Okay, but what is the force? Now, we have a vector right here at a 30-degree angle of 15 pounds. Okay. But which direction is our wagon moving? Okay, it's moving horizontally, correct? So the only component of force that's actually acting on this wagon is which component? The horizontal component. And how do we find the horizontal component of a vector?
You take the inverse cosine, or not inverse cosine, you just take the cosine.
We take the cosine times its magnitude. Okay, so we're going to take 15 times the cosine of 30 to give us the horizontal force that's the only one acting on it, since it's moving horizontally, multiplied by 30 feet. And here we go. Talking about work, we're talking about the pounds.
This year.
What'd you say?
Oh, we did work earlier.
Yes, yes. We did work with integrals.
No, I know. I'm just saying, wasn't there another like unit like not the pounds?
Oh.
Yeah. Why do we write it in newtons?
Newtons are 2 bits.
Good for the America.
Because everything in a textbook in the United States for math is written in feet and inches and pounds and all of our,
But newtons looks bigger.
sorry.
Yes.
Yes, you can cover it. Okay, so if you want extra practice on all or a portion of the topics covered, since we have began this chapter, then here are some extra examples. I will eventually get a key up. Okay, you don't have to do this. It's just extra practice. I think some of you may want it.